So what I'll do is I'm going to do this and call it a day for today. Will that be okay? And Friday I'll pick up the rest because I just get an idea of how this is going to flow. That'll be good.
Okay.
So now, so I'll talk about this. Alkenes and alkynes are hydrocarbons and contain double. Okay. So here we are going to discuss the next two categories of hydrocarbons, alkenes and alkynes. You can see the name, the terms have changed a little bit. We are talking about ENE and YNE. These are hydrocarbons with a double bond and a triple bond. And where are these double and triple bonds? At least one double bond between two carbon atoms is an alkene. At least one triple bond between two carbon atoms is an alkyne. So these are families of hydrocarbons that contain double and triple bonds respectively, are called unsaturated hydrocarbons because they do not contain the maximum number of hydrogen atoms and react with hydrogen to increase the number of hydrogen atoms and become alkanes. So these alkenes and alkynes are short of hydrogens and they are very reactive and are able to add on the required number of hydrogen atoms to convert to alkanes. So alkenes contain one or more carbon-carbon double bond. You can say this is the first alkene, carbon-carbon double bond. So the bond angle is 120 degrees. And the tetrahedral arrangement when carbon has 4 bonds was 109 degrees. So each carbon atom in the double bond is attached to 2 hydrogen atoms and has a trigonal planar arrangement with a bond angle of 120 degrees. And ethene, this is the first alkene. Now this is the first hydrocarbon we just looked at, ethene, and commonly known as ethylene, and it is an important plant hormone, and it is used in promoting the ripening of fruits such as bananas. It accelerates the breakdown of cellulose in plants, which causes flowers to wilt and leaves to fall. So ethylene, these are some commonly used uses of ethylene. Now again, it has, we were back, carbon-carbon double bond, unsaturated, okay. And these are alkynes, carbon-carbon triple bond. This is ethyne, commonly called acetylene, is used in welding in which it reacts with oxygen to produce flames, very high temperatures. Now here the learning goal will be to identify structural formulas of alkenes, cycloalkenes, alkynes, and write their IUPAC names. So, okay. Now, identify the following compounds as alkene or alkyne. So I'm looking at this compound, and remember the definition of alkene. Alkene is a hydrocarbon which contains at least one carbon-carbon double bond. So I look at a double bond. This is a double bond. There are 1, 2, 3, 4 electrons being shared in 2 bonds. Triple bond, 1, 2, 3. 3 pairs of electrons. So a double bond, a compound with a double bond is an alkene. A compound with at least one triple bond is an alkyne. So that's the first, alkene, alkyne. 1, 2, 3, 4, 5, 6, 7, 8. Oct, 8. So let us see. Oops, we went back. Okay. Alkene, alkyne. We are identifying that using the double and the triple bond. Okay. The IUPAC names, we are going to talk about the IUPAC name. It is similar to naming the alkane, but we replace the A and E with the E and E when you have a compound with a double bond. So this is your alkane, single bond, alkene, double bond, alkyne, triple bond. So ethane, ethene, ethyne. Propane, 1, 2, 3. Propene, propyne. And these are your skeletal structures of the 3 hydrocarbons here. The category is alkanes. ANE, ENE, YNE. So cyclic alkenes are cycloalkenes. So now again, naming guide. Step 1, name the longest carbon chain. Number the chain starting from the end nearer to the double or triple bond. Give the location and name for each substituent alphabetic order as a prefix to the alkene or alkyne. So let us see here. This is a alkene. This is an alkyne. So count the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to go with 5. So, oops, went forward. 6. 1, 2, 3, 4, 5, 6. So here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So feature is a double bond, alkene. Replace A and E with E and E. So 5 carbons, pent. Replace A and E with E and E. 6 carbons, 1, 2, 3, 4, 5, 6. Triple bond, Y and E. Replace A and E with Y and E. 6 is hex, hexyne. Now, number the carbon chain starting from the end nearer to the double or triple bond. Once you have identified the alkene, alkyne, the base, you are going to start numbering. So if you start here, 1, 2, 3, 4, 2, carbon 2 has the double bond. If you begin at this end, 1, 2, 3, carbon 3. So I'm going to use the lower number, carbon 2. Now, here 1, 2, 3, 4, 5, 6. If I begin here, 1, 2, 3, 4. So 2 hexyne is what I'm going to pick. I am going to number the carbon atoms, and the nearest to the double or triple bond is the numbering I'm going to pick. Next, step 3. Now, give the location. So I have numbered the chain already based on the double or the triple bond. So this is carbon 1, this is carbon 2, 3, 4. Carbon 4 has the substituent. So the double bond takes the lower number, and then the substituent will get the number it is located at. So this is a methyl. There is your carbon CH3. So 4-methyl. Carbon 4 has the methyl. Carbon 2 has the E and E double bond. So here, 2-hexyne, I do not see substituents. It is just one straight carbon chain with a triple bond. So 2-hexyne. There are no substituents in this compound. So now cycloalkenes. Alkenes are hydrocarbons with double bonds, and cycloalkenes are hydrocarbons with a double bond in a cyclic structure. So now in this, I'm going to first assigning double bond when the substitute. Okay, now let us go count first. Where do I start counting? 1, 2, 3, 4, 5. I count the ring first and see what is my base cycloalkene. So I'm counting 5. So 5 is pent, pentene. Now I have to number the carbons because I have a double bond and a substituent. So I'm going to start numbering nearest to the double bond first. So 1, 2, 3. So this takes number 1 and the substituent takes number 3. So 1, 2, 3. Now if I go 1, 2, 3, 4, so I'm going to go to the lowest possible number. So the carbon atoms in the ring are numbered to give the double bonds the numbers 1 and 2, then the lowest possible number to any substituents present. So if, and that was why we went this direction 1, 2, 3 and didn't go 1, 2, 3, 4. We want to pick the lower number for the substituents as well. So this is 3-methyl pentene. It is understood that the double bond is between carbon 1 and 2. We did not mention the double bond. That tells us that the double bond starts off with carbon 1. So name the following alkenes, alkynes. So do you see an alkyne? I'm seeing 2 alkenes. And how did we figure out they're alkenes? They're a double bond, double bond. So I'm going to first start counting the base cycloalkene. 1, 2, 3, 4, 5, 6. Hexene. 1, 2, 3, 4, 5. Pentene. So 1, 2, 3. 1, 2, 3, 4. Because when I'm numbering, this has no substituent, so I can just say cyclohexene. But when I come here, there are substituents, so I have to number. So I will start with the double bond carbon 1. 1, 2, 3. So carbon 3. Or I can go 1, 2, 3, 4, 5. So I'm going with the lower number. 1, 2, 3. Carbon 3 has 1, 2, 2 methyls. So let us see. Cyclohexene. Now 1, 2, 3. Carbon 3 has 2 methyls. 3, 3, dimethyl. So you have 2 methyl substituents in carbon 3. So you're going to repeat 3, 3. There is a dash here. Dimethyl cyclopentene is how you name your cycloalkane.